Hey, good morning, everybody. Um, Today is day 10 of Math 133. And today we're going to be going over the chapter 4, project number 2. Okay. In addition to that, you'll want to fill out your 5.3 lecture notes. Those are going to be due on Thursday, but try to do them before tomorrow so that Elaine and Cindy can go over 5.3 stuff with you. And again, you are welcome to work ahead on the lecture notes. I don't want you to have to turn anything in late. We don't want to lose points on that stuff. So uh, feel free to get ahead on the lecture notes, okay? Um, we have coming up our midterm exam. The midterm is on October 16th if you're taking it with me in Zoom, okay? We'll talk more about this as we get closer, but uh, you also can take the midterm at the testing center. You can take it on that week on Tuesday, Wednesday, Thursday, or Friday. So that's October 14, 15, 16, or 17. If you're planning on taking it Friday, October 17th, you're going to want to reach out to the testing center and make an appointment because their hours are not they're not open like all day long. Okay. Um, okay. So like I said, we will talk more about the midterm as we get a little bit closer. Um, but make sure you've got that time set aside. Uh, so on October 16th, if you're taking it with me in Zoom, we will be starting at 9 a.m. and then we will go until noon. Okay, so normally we get on at 9:30, go till 11. So you'll get a full 3 hours to take it if you need to. Last year, everyone was done around like the last person was done like in 2.5 hours. So don't stress about the time. You have enough time. Okay. If you feel like you need more time, then taking it at the testing center, you have unlimited time, that's probably going to be a better option. Okay. Okay. Uh, for the midterm, you're allowed to have your yellow packet with you, the yellow exam notes packet that's in your course pack. You're also allowed to bring your you're allowed to bring a 8.5 by 11 piece of paper with whatever you want written on it, front and back. I believe you are allowed to bring your own laptop to the testing center, uh, but you might want to contact them and double check. Um, so, uh, I mean, if you bring it and they say no, you can't bring that in, then that's fine. You can just use the computers there. But make sure you have your username to log into Pearson for StatCrunch, username and password, because you're going to need that. Um, And one other thing to mention, so on October 14th, is when we were originally going to cover the sample midterm exam. Well, there's no class on October 14th. So it's bad timing, but we're going to be talking about the sample midterm throughout the next couple of days. So we'll open it up and we'll take a look at it on Thursday and then next week on Tuesday and Thursday as well. Any stuff that we don't cover, Elaine or Cindy will look at with you guys. But yeah, we'll be looking at the sample midterm over the next week and a half. Okay. So anyway, yeah. Like I said, not great timing, but it is what it is. The sample midterm is one of the best ways to study for the midterm. Uh, the actual midterm, I believe, is 9 pages. But the sample midterm is huge. So um, it's pretty big, give you a lot of chances to study. So um okay. That all said, um we are going to today be looking at Chapter 4, Project 2, and we're going to be looking at our arm lengths versus our heights. So you guys were supposed to fill out the survey for that back here on day 8. So there was a link to the survey. If you haven't done it, I've marked it as a 0. I'm not going to accept that one late because we're going to need that data today. Okay. But most people have already filled it out, so you're good to go. Um, in Canvas, if you click on the Chapter 4 Project 2 in Canvas, there's 2 links that we're going to need here. The first one is the link to the Google document. And if you click on that, it'll bring you here. And we will need to do File, make a copy. Most of our projects are going to be in Google Documents. So just make a copy here. Make sure I save it in the right spot. You can save it in My Drive or wherever you want to save it is fine. Oop, I don't want to save it in the summer one. I want to put it in the fall one. All right. Um, so let's see here. So this activity uses forearm length and height data collected from our class to determine a linear model. So we've made that data set available to you in StatCrunch. So if you go back to Canvas, there's a second link here. Fall 2025 data is here. Try that link. Let me know if it has if you have any issues getting to it. So in Canvas, it's the second link. Click on that. You'll have to sign into StatCrunch, right? Uh, is anyone in that data or have any errors? Let me know if it opened for you or not. Andrew has an error. Elaine, did you get an error? Can you try that link? I'll
I
drop it
was
in the
just
chat
getting to
as
click
well.
on it. Didn't click on it yet. Let me look.
That's okay. I'll drop it in the chat as well.
Yeah, that gave the link in the chat gave me an error too.
Let me try. My data. Yeah, it's because I made it private. I
Well,
thought I
that's
might
an
get
easy fix.
it. Share it with all set crunchy. Yeah, that's fine. All right. Try it now.
It's good. It worked for me.
Work for you? All right. Andrew's in. All right, we're good. All right. Sorry about that, everybody. When you make a data set in StatCrunch, yeah, you can share it with everyone or not. So it depends on what you want to do. So just like when you're in Google, a Google document like this, you get to choose who you share it with, right? Do you want to share it with just people with the link or you want to share it with the whole wide world? What do you want to do? So anyway, so here we have our chapter 4 project 2 data. Now this is actually everyone who is taking uh Math 133, so it's not just everyone in our class. Um uh yeah, so if there's anyone who's like, hey, I don't want my data shared with everyone. I'm a little sensitive about my height or you're sensitive about your forearm length, I guess you that could be too, right? So let me know and we can take you out of this list. So um anyway, so let's go and look at what we're gonna do here today. So um create a scatter diagram of the paired data set using arm length as the explanatory variable. Okay. So um to do that, we'll do graph and then scatter plot. Okay. So we'll go to graph and then scatter plot. Our X variable will be forearm length. Now you'll notice that uh, it's listed as what is the length of your inner forearm to the nearest centimeter, blah, 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 right? This is probably a pretty terrible data label, okay? So I'm going to change that. You don't need to, but it's going to probably make our lives a little easier. So forearm, yeah, I'll just do forearm. We could do forearm length, but I'll just do forearm. And then this one, what is your height? What is your height to the nearest centimeter? Yeah, we don't need all of that. We just need height, right? Probably don't need what is your first name, you could just write first name, last name, right? All right. So now that I've got that, um, let's try it again. Graph, scatter plot. X-axis here is X labels forearm. Wait, I'll hit compute. All right. This is a crazy looking graph. So I've got uh like a bunch of the data like all scattered around here, but looks like it's in a pretty straight line, right? If I tried to draw a line through here, it'd go through this stuff, right? And then I've got this one dot hanging out over here. That's probably an outlier, right? Whenever you're dealing with real world data, this happens. You get outliers, right? In the class, we've talked about outliers, but a lot of times with our data that we've given you for StatCrunch or given you for things, um, it's pretty clean. We've cleaned it up. We've removed any kind of issues, okay? But the projects give us a chance to work with real data, data that you've gathered. In October, we're going to be gathering data about like some candy we're going to be getting. And there's going to be weird things that happen. Weird things happen in the real life, in the real world, okay? If I were to use this graph and I try to do, our normal regression, a linear regression here, we're going to have issues, right? Because what's going to happen is StatCrunch is going to try to draw a line through this data, but it's including this guy over here. So it's like, well, I can't draw my line up and down like this because that's too far away from this dot. So it draws the line like this to try to get a little closer to that dot. Maybe it gets a little farther away from these, but that regression is a hot mess, right? Uh, you can see here that our correlation coefficient is almost zero, right? We know that when the correlation coefficient is close to zero, there's no linear relationship. But I can see these kind of are in a line, right? Not including that outlier. I think that these are in a pretty good looking linear relationship. So, uh, so I'm going to try to deal with that outlier. So if you want to, you can submit this graph as is, and that's totally fine. But whenever you're working with real world data, there's a part of the data where you have to clean things up. Let me hover over this guy. This guy is at 154 centimeters for the height and 243 centimeters for the forearm. So that's saying that someone's forearm is longer than they are tall.
A little data entry error, maybe.
Yeah. So I'm pretty sure that's not accurate. I'm pretty sure maybe they had them switched. Maybe they meant that their forearm was 154 and
It's
their
still
height
pretty
was
long.
still 143. But I still think that's wrong because if you look at these forearms here, people have got forearms that are 22 centimeters, 25 centimeters. I don't I don't think that this person has 150 centimeters. Yeah. So let me find that
It's
one.
toward the bottom.
What's that?
It's toward the bottom.
Yeah. So, and by the way, if this was your data point, we're not judging it. Gave you the full 10 points for filling in the survey. This kind of thing happens in the real world. So Courtney Gibson, you're totally fine if you're on the call. We're not making fun of you or anything. Looking at this, so whenever you have outliers like this, you have to go and figure out what happened, okay? Sometimes that means going and talking to someone. Sometimes that means making a guess of what you think it should have been. Sometimes it means just deleting that point altogether and just saying, we're not going to include this one in our data point because it's going to throw off our results, okay? Remember that least squares regression is not resistant to outliers. You have to deal with them. Okay. Unlike median and interquartile range, you can just be like, I don't care if I have outliers. Median's resistant. It's resistant to skewing, so it's all good. But anyway, so looking at this, Courtney's not on the call today, but if she was, I we could ask her what happened. Looking at this, it appears to me that her height is actually pretty reasonable, 154 centimeters. And that's in the range of these numbers, right? Maybe it's a little taller than Ariel, a little shorter than Aaron. Okay. Her forearm, though, to me, it looks like she made a math error when she was doing a conversion, and she actually meant 24 centimeters, 24.38, not 243.84. Okay. So that's what we're going to go with for her. Okay. Again, there's not really there's not really a right way to deal with outliers. You could just leave it in the data set and say, well, sorry, our data is just not accurate, and this is what we get. Okay. But most of the time you don't want to do that. So I'm going to change this to 24.3. 24 point, oh, 24.3. Okay. And I'm going to redo this graph here. Graph, scatter plot. All right. That looks much better. um, I still have an outlier that I'm not happy with. This guy right here. So if I do my regression, what does it look like with my regression here? So now my line goes like this, and you can see that it is pretty close to this one over here, but I think there's an error with this one. There's still an error with this one, this dot over here. This person is 166 centimeters tall, which sounds right. Um, but their forearm is only 6 centimeters. Um, 6 centimeters is 2 inches. Now, um, that's certainly possible, right? We're not going to discount that maybe they have, some kind of dwarfism. Although, if that was the case, their height shouldn't be 166. So I still think that this is an outlier. So this is probably another one that we would want to address. What kind of correlation coefficient do I get here? So my correlation coefficient isn't bad. I got 0.52. But if I find that one's toward the top. You can see that most of these, or no, it's actually at the very last one. There we go. Most of these forearms are like 27, 22, 16. So I'm guessing that one of two things happened. Either she meant to write, and again, Ariel, if you're on the call, that's totally fine. I gave you the full 10 points for filling out the survey. This kind of thing happens when we deal with real world data. We get errors sometimes, and we just deal with them. Okay, that's our job as a data analyst, and that's why, one of the things with using a human data analyst versus trying to just run everything through AI. AI is going to not be able to handle this. Um, so AI is never going to replace everything. So I think that either she meant to put 16 or she measured her forearm in inches. We live in America, so we're used to inches, and then didn't convert this one to centimeters. What would 6 centimeters be in inches? Let me see here. 6 centimeters or 6 inches times 2.54, 15. So 15 is 16, somewhere in that range is probably accurate. And again, changing this data might not be the right thing to do. Maybe we want to start by going back to aerial and remeasuring, or maybe we just want to exclude this one entirely. I'm going to change it to 16. Whether she meant it as 6 inches converted to 15 centimeters, or if we just put it as 16 centimeters, either of those, we're in the right ballpark. Um, and this brings up another point. Your data is not going to be 100% accurate. I have people at my work who are always like, why is this data wrong? And it's like, well, it's entered by humans. Humans make mistakes. It's never going to be 100% accurate. But we can often make the right decision, even if our data is like 90% accurate or 95% accurate. Okay. So we've talked about, uh, our data being 95% accurate. We'll talk more about 95%. 95% is kind of the standard in statistics. When we start talking about confidence intervals and start talking about hypothesis testing, we'll see 95% a lot of the time. So anyway, if I was to redo this now with uh, our graph and then our scatter plot, everything looks pretty good. It's kind of scattered all over the place. Maybe there's still a few outliers. I'm not going to worry about them. I think that everybody's kind of in the right ballpark at this point. If we did our regression on this, what's our correlation coefficient? Correlation coefficient now is 0.53. So removing that second outlier, it improved it. It didn't make it perfect. So we probably didn't need to deal with that second one. We probably could have left it at 6 centimeters. But anyway, let's let's actually do the project now. Um, all right, so let's get a scatter plot diagram of the paired data and put it in here. All right, we can do that. So uh, you'll go to graph, scatter plot, and then grab a snip of that. Put it in here. So Elaine, when I changed those two numbers, did it change it for you as well, or is it still showing up as 243?
I wasn't changing them with you. I was just watching what you
Oh,
were doing. You want me to change
that's
them?
fine.
I can.
What's that? Yeah,
Um,
yeah.
I was
I,
wondering,
I'm
yeah.
curious if it changes it for everybody or just me. So if I scroll down at the bottom, no, it's still showing 243 and 6. So you guys will
Okay.
want to change those in your data yourselves. So
Yeah.
otherwise
Oh,
you're
oh, I'm sorry. I see what you meant. I thought you wondered if I changed my graph. No, it
oh
didn't
no,
change.
yeah. Yeah. No, I wasn't sure if change. I think I have to hit the save button if I want it to be available for everybody, but that's okay. So just change this one. You probably don't need to change the 6. It didn't really end up making as much difference as the 243 did, but
Yeah.
okay. So graph, scatter plot, here it is. Save, paste that into question number 1. Question number 2, judging just from the scatter diagram, what type of linear relationship appears to exist in the table? So strong positive, strong moderate, weak, no relationship. So to me, I do see a line kind of this way. If I was going to draw a line, it'd be going this way, right? because there's no dots up here. There's not a lot of dots down here in the lower right corner. I would say it's a positive slope. Uh, but the dots are still pretty scattered around, so I don't think it's strong. Do you guys think it's moderate or weak? I'll go with whatever you think.
Looked more moderate before, when
Moderate. You want to go moderate,
seems like
positive?
moderate.
Explain why you think this is. So, uh, the dots are generally upward. Yeah, they're generally headed upward. It's not, you know, they're definitely not all in a straight line, right? Also, it looks like there's kind of some clusters and lines, right? Do you see how all these dots are kind of in a vertical line right here, and then there's another bunch of dots in a vertical line. What's happening there is people are measuring just to the nearest centimeters. So this is probably 23 centimeters, or sorry, 22, 23, 24, 25 centimeters. Some people are using decimals. So like this one is uh, at like 24.9, but some people didn't. Some people only measured to the nearest centimeter, which is fine. Okay. Again, your data is not going to be 100% accurate. So you'll notice some people are using decimals, some people are not. So if we wanted to be more accurate, we could have gone back and said, measure yourself, but make sure you measure to the nearest centimeter. Or if we want to be more accurate, nearest millimeter, right? All right, let's go down. All right, question number 3. Using StatCrunch, conduct a simple linear regression on our dataset, gathering both the output and the scatter diagram with the regression equation drawn. So we're going to paste two things here. We're going to paste the results and then also the graph. Okay. So let's come back over here and let's go to stat, regression, simple linear. Okay. All right. So our x-axis is going to be a forearm. Y-axis is height. And you don't need any of this other stuff. You just hit compute. And we're going to grab all this stuff right here. Put that into our. All right. So there's all of our numbers. We got our equation and our correlation coefficients, everything. Now, if you go to StatCrunch and you hit this arrow in the lower right-hand corner, it'll take you over to the scatter plot with the linear regression line drawn in. Okay. All right. You can also do options copy. Oh, I guess it doesn't work on this. Yeah, that's fine. So you could have just grabbed all the data like this if you wanted. All right. Question 4, state the value of the linear correlation coefficient for this data. So mine is right here, 0.537. We'll do 3 decimal digits.
Did you get the regression line, Andrew?
Oh, Let's go back here. So you'll go to graph, or no, not graph. That's how you get the scatter plot. To get the regression, you do stat regression simple linear. Stat regression simple linear gives you this. Your x-axis is going to be your forearm, y-axis will be height. We'll hit compute, and that's going to give you these numbers. And then if you hit in the lower right corner, there's an arrow, and if you hit that button, it'll take you here. So you can see that there's two pages to this regression. The first page is all of these numbers. The second page is the scatter plot that we did before, but with the line drawn through this time. And here's our correlation coefficient. So 0.537. Now that's the correlation coefficient that I have after I fixed those two outliers. If you didn't fix either of the outliers, you're going to get a different correlation coefficient, which is going to be kind of pretty bad. But definitely want to fix the first one. As I said, I don't know if we needed to fix the 16. It didn't change our correlation coefficient very much. But anyway, uh, so that's my and like I've said before, you don't always get the same answers in the projects that I get, right? So if you didn't change those outliers, that's okay. All right, question 5. Does the value from number 4 support or contradict the strength and direction of the data from number 2? So on page 255, we can see um, if on page 255 you can see where the correlation coefficient lands on that number line. So ours is 0.53, which is in the moderate positive, so just barely, right? 0.5 is the cutoff for weak positive, but in our case, yes, uh, this is a moderate positive. So we were right on our guess with moderate positive. All right. State the value of the coefficient of determination for these data. So that is r squared, which in this case is 0.288. All right. Interpret the value from number 6 using the context of the situation. So the interpretation of the coefficient of determination is at the bottom of page 255, and it goes, take your coefficient, switch it to percent, and then say this percent of the total variation in height. So you write out what y is. In this case, it's height. And you write is explained by the least eta dash squares regression. Okay. So 28%. That doesn't sound that accurate, right? We're moderate positive. So 28%. If you told me your forearm length, I could guess your height with 28% accuracy. So, all right, state the equation of the least squares regression line. So the equation is this one right here. Okay. And if you didn't change the headings, then it's going to look like a crazy mess, but that's okay. The main thing is you need your intercept and your slope. So you've got those in this table down here. So my equation is, move this a little bit for me. Try to put it on the same screen. Here we go. Oh no, it's not going to let me do that. Oh, it will if I do it the other way around. There we go. Y equals 126.50 plus 1.78x. Um, I usually like to put my slope, my slope and my x first. So if you want to switch it around and write y equals 1.78x plus 126.5, you can do it that way. Or you can just write it the way that they list it here. Um, so either is fine. State the value of the slope. Slope is 1.78. That's what I have here. And interpret the value of the slope of the regression line. So there is a script for that in the middle of page 255 for the interpretation of the slope. And it starts with if, and then you write out what x is. So if x increases by 1, so if the form length increases by 1 what? 1 centimeter, because we were measuring in centimeters. Then y, height, right? So when x is in when x increases by 1, if x increases by 1 unit, then y is expected to either increase or decrease. So if your slope is negative, then it would decrease. In this case, longer someone who's taller has longer forearms. Someone who's longer forearms is probably taller, so it's increase by approximately. Then you write out the slope 1.78 and you give the units for A, which is also in centimeters. If forearm length increases by 1 centimeter, then height is expected to increase by approximately 1.78 centimeters. Okay. State the y-intercept. Y-intercept is 0, comma, 126.50. So that's our y-intercept. Explain why the y-intercept does not make sense in the context of this situation. So it is possible for someone to be 126 centimeters. That's very short, but we would say impossible for, and usually the 0 is the problem. It's impossible for a person to have 0 centimeter forearms. You have 0 centimeter forearms, and that means your hands are attached to your elbows, which I guess it's not impossible, but it's a very weird scientific condition, if very weird medical condition, I guess, if that could happen. So that doesn't make any sense. Uh, all right. So this one, you guys will have to fill in your own answer. What value did you give as your forearm length? So if you don't remember, that's why I included everybody's names here. Uh, so again, if you don't feel comfortable with having your height shared with everyone, let me know and I can remove you from that. But if you don't remember what you put down, you can go find it. So I'll say for mine is 20 centimeters. Use the regression equation to find your predicted height based on your forearm length. Okay. So mine, I put 20. Okay. Um, you might have had 25 or 19.5, whatever you put down. Okay. So what you do now is we plug that into our equation. Now, is this number, so I'm using 20, is that a y value or an x value? It is an x value. Thank you. So I have, this is my formula right here for my line, right? I'm not going to write x now, right? I'm going to write whatever number I pick. So it's 1.78 times 20. All right. So how much does that come out to be? So my predicted height is 162.1. Okay. Now yours is going to be different because you put in something else. So whatever your predicted y value is, that's what you're going to put here. Now this is technically y hat. I'm not going to write y hat here. I don't even know how you would type that on a keyboard. But this is not your actual height. This is what the regression is predicting your height will be based on what your forearm length is. Okay. Calculate your residual. So show your work, include units. So residual, there's a formula for that at the bottom of page 255. It is, didn't want to do that. Residual equals your actual height minus your predicted height. Okay. Your predicted y in this case is the number that you got in number 14. Okay. Your actual height, you come over here. What's your height? Find that number and put that in here. Okay. So what's mine? 5. Let's do, let me figure out what mine is real quick. 7 divided by 12. 5, 7, 12. All right. So my actual height is 170.2. Okay. This predicted for me 162.1. Okay. So I'm going to subtract those two and I get 12.1 centimeters. Okay. So the first number you put in is the number, is your actual height, what you actually measured. Okay. And then the second number you put in is just the number from question number 14 when you plugged in your X value and you subtract those. And you might get a negative number, and that's fine. Okay. If you do get a negative number, make sure you mark it as negative, right? And then were you shorter or taller than predicted? So the prediction said that I was going to be 162, but I'm actually a little bit taller than that. So taller than predicted because residual is positive. Okay. Or vice versa, shorter than predicted because my residual is negative. Easy as that. Right. All right. Use the regression equation to predict the arm length of Andre the Giant. He was a wrestler. He was in Princess Bride. If you haven't seen that movie, you should. Who was 223 centimeters tall. Show your work. Give three decimal places and include units. Okay, so we're going to use our equation again. Where was that? That was question number 8. So I'm going to go back and get to grab that. Yeah, he was a wrestler and he was defeated by Hulk Hogan back before Hulk Hogan was well known. I guess maybe he's not well known anymore either. So I don't know. Anyway, okay, so now that I have this, 223, I'm going to plug that in, but is that an X value or a Y value? I'm going to replace either X or Y with 223. Am I replacing X or Y in this case? So looking at our graph here, the x-axis is forearm length, y-axis is height. So 223 is at a height or a forearm length? What do you guys think?
The word tall is next to it.
Yep. So that is a y value. Yep. So I'm going to plug that right here. So 223 equals this, and I need to find x. Okay. So to find x, I'm going to start by subtracting 126.5 from both sides. Okay. So 223.5 minus 126.5, I get 97. 97 equals 1.78 times x. Okay. So all I did was subtract 126. Next, I'm going to divide both sides by 1.78. So 97 divided by 1.78, 54.49. Okay. So that means that we predict that his forearm was 54.49 centimeters long. Okay. Oh, three decimal digits? 494. Okay. Question 18. Explain why the value for number 17 is outside the scope of our model. So 223 is his height. Do we have anyone in the class that is that tall? Well, let's go look at our scatter plot here. So the tallest person we have in the class is like 197. Let me, where's my graphs? I think I got rid of my graphs. Oh, that's not my updated one, is it? That's okay. Um, tallest one right here, 198 centimeters. So 223 is even taller than that. So that means that that is outside the scope of our data. So that means that, let's go back over here and write on. No one in our class is close to 223.5 centimeters tall. Okay. So because of that, um, our linear regression equation is not a good prediction for him because it's outside of our scope. Okay. You could have also written 54. You could say no one in our class is close to a 54 centimeter forearm, right? All of the numbers for forearms were like 18, 25, 29, 26, 30. No one's close to 54. So you could have written it as no one in our class has a forearm close to 54 centimeters. Either of those answers is fine. Okay. All right. Looks like that's it for the chapter 4 project number 2. So we're going to come up here to the right upper right hand corner and hit share. And then we're going to change the restriction to anyone with the link. Copy that link. Scroll to the bottom here. Web URL. We'll paste that in here. And submit assignment. Get our confetti. Woohoo! We're done. Okay. All right. So, that's all I have for you today. If you have questions, feel free to stick around. I did record the entire thing, so if you need to go back through and rewatch any of it, that's fine. We're going to be talking about the Chapter 5 review on Thursday, and we will also be starting working on the sample final exam, and we'll talk a little bit more, or sorry, sample midterm, and we'll talk a little bit more about the midterm this upcoming Thursday. So that's one you don't want to miss, okay? All right. Thanks, everybody.